Welcome back to the Internet Report, where we uncover what's working and what's breaking on the internet, and why. This week, we're covering the recent AWS outage that impacted many services, including Slack, Atlassian, and Snapchat. We'll also discuss a pair of Microsoft service disruptions and outages at YouTube and Vodafone. And as usual, we've got the latest global outage numbers. I'm Barry Collins, and I'll be hosting today with the amazing Mike Hicks, Principal Solutions Analyst at Cisco ThousandEyes. As always, we've included chapters in the description below, so you can skip ahead to the sections that are most interesting to you. And if you haven't already, we'd love you to take a moment to give us a follow over at Spotify, Apple Podcasts, or wherever you like to listen. The recent AWS outage caused major disruption among many leading websites and services. Explain what happened here, Mike.
So this was an outage that impacted AWS's region US East 1. It lasted just over 15 hours or around 15 hours with some lingering impacts going on after that. It was actually impacted quite a few services, so some big names there, so Slack, Atlassian, Snapchat. So these services that sort of had global reach. From a ThousandEyes perspective, then we actually started to see it looking at some packet loss, which was appearing at the AWS Edge network. So we first saw that around 6:49 UTC. So we started to see this increasing packet loss. So we saw these going into the US East 1 region, which was in Ashburn, Virginia. So it's actually that boundary. It was actually showing up as a forwarding loss. So we started to see that increase there. And why that's important is because that tells us effectively that the connectivity going into that region is fine. So the network conditions itself is good. So at the start of that outage, what is actually sort of manifesting itself was intermittent issues. Sometimes requests or connections would get through, and then other times they actually wouldn't. And then what happened is actually went over. It sort of evolved into this chain reaction or this cascading impact where we started to see different effects on different services going through there. But effectively then we sort of went through these waves. We saw this in two distinct waves. So we started to see the loss and the outage, and then we saw the impact of that. And then there was a little period of stability before then it actually went in again to this second period, which was the bit that actually lingered on.
The root cause turned out to be a DNS problem that triggered the cascade of issues you mentioned. Tell us more about that.
So AWS initially said they had DNS problems with their DynamoDB. In fact, what that meant was they couldn't resolve the name or they couldn't get the access to those DynamoDB endpoints. What they actually then did was they started to fix that issue. So they resolved that issue where they could get to that point. And what this then started to do was to reveal underlying issues. So then they had these DynamoDB access points, we could actually get those points. And then it started to see this issue with these health checks underneath those. So as they effectively started to pull one thread, the jumper started to come undone. So it was this cascading impact. So we saw that. And what it actually turned out to be was this internal monitoring for the network load balancers. So these health checks, they do a check to make sure the destinations or the endpoints of the services are healthy. And if they're not healthy, then so it's not going to route traffic to those. So if we don't have a health check or we can't get to that, then we can be starting sort of to forward traffic either to unhealthy endpoints, or we say they're all unhealthy. We actually can't route to anywhere. So effectively, everything starts to shut down. So this was then this cascading. So as we started to do this, you sort of had this load issue came up then sort of jobs started to queue and services started to queue right through there.
On many of the sites with issues, performance was patchy or slow rather than knocked out entirely in some cases. Explain why that would be.
So each service is going to have its different dependency chain and different areas within that architecture itself, so where they actually hit it. And we sort of saw this across different services. So some of the services are impacted early on, and we could start to see that, and then they weren't taken out completely. They were just sort of slow or laggy. And then when we got into that area of stability, before we then came into this second wave, they never really had an issue again, or they were laggy. Whereas other architectures or other applications and services had this disruption right the way through. And then similarly, we had this other situation where that first case where we couldn't reach those endpoints didn't really impact it. But when we started to have these cascading failure situation in the back end, it impacted those. So it's really, think of it like this situation where you're trying to untangle the Christmas tree lights. Sort of, if you start to pull it right through there, you're just going to end up with a bigger knot. So you've got to go through and sort of really start to untie those things together. If we're going to do that, we're going to have a degradation necessary, not complete failure right across there. This goes back to our Christmas tree analogy. If I'm actually then going to sort of pull a little bit of a knot out there, I could actually somehow tangle it up again and have a further knot down there. So I have to effectively go through and say, right, I'm going to fix this one there, and then it might reveal another issue underneath, or it might have this cascading problem, or I might be masking something that then sort of moves away or moves a problem down the chain.
Amazon wasn't the only hyperscaler to experience issues in the past few weeks. Microsoft Azure experienced an outage on October the 9th that affected Azure Front Door. Explain what Azure Front Door is and what you saw here, Mike.
So think of it as Microsoft's global front door. It's their CDN and routing service that effectively sits between the users and the Microsoft services, so 365, Azure Portal, and those types of things there. It has three main jobs. It's to route the traffic to the best server, it caches content sort of closer to the user, and it acts as this security layer. It is that front door that sits in front there. Now what happened, this on October 9th at around 7:50 a.m. UTC, there was a software defect in the Azure Front Doors infrastructure. This had a cascading effect to the edge sites in Europe and Africa, and they started crashing and going down there. The remaining healthy sites then got sort of slammed with this redistributed traffic because Azure Front Doors starting to sort of do the traffic. So then we had this sort of overload scenario itself. So within that area there. So remember, we're routing to the systems within our region because we want to go to the closest users there. And if you had some of these clusters actually crash, then we're going to route traffic to the other ones. And then you have this cascading impact of this load increasing where it starts to hit.
This issue only appeared to affect customers in Europe and Africa, with the Americas and other regions largely unaffected. Why might that be?
Azure Front Door operates through regional clusters where each region runs its own control plane, its data plane infrastructure. So we don't know specifically what happened in this case, but there's several possible explanations which might explain what happened in this scenario. Different code versions is the first one there. So Europe and Africa clusters might have actually been running a different version. And where this bug was a latent bug there, if you're actually rolling out these code versions differently, and staggered deployments are not uncommon, specifically for this type of thing. So we don't want to have these rollouts all at once when we take everything down at once there. Then it might even mean some sort of regional configuration pattern. So if you think of things like GDPR, they lead to region-specific configurations, and this might actually trigger some sort of edge case there as well. The last one is sort of concentrated failure, where the regional clusters failed and the traffic redistribution against those local ones sort of just amplified the problem specifically within that region. The thing about having this regional control there as well, and the way it's effectively been set up there, is that this regional isolation actually prevented this from sort of going global. America stayed up, we had this connectivity, and effectively, because the way that front door works, some areas could have actually rerouted and just have this latency and this lag around there as well.
On the same day, another Microsoft issue did impact US customers who were trying to access Microsoft services through AT&T's network. What happened here?
So this was same day, different problem. So October 9th, but this time it was around 6:10 p.m. UTC. But it's actually unrelated to that Azure Front Door problem there. Now, what we actually saw was AT&T customers sort of nationwide couldn't access Microsoft services, but other ISPs were fine. So they had connectivity coming into Microsoft itself. And when we talk about couldn't access Microsoft services, this was actually effectively the way that AT&T directly peer into Microsoft to provide those connections themselves. So we could start to see that the network traffic could traverse across AT&T's network. And again, we were seeing this drop at that edge point. So it was actually at the peering point or the edge nodes between Microsoft itself. Again, manifested as a forwarding loss, which meant that the next stage there, or the next hop to that, was where we couldn't actually get traffic to. So we started to have a loss. The cause of the problem was actually put down to a network misconfiguration, affecting that connection between Microsoft and AT&T specifically. Microsoft themselves then used sort of separate configurations for different ISPs, and this one specifically impacted the AT&T connection itself. The issue itself was resolved around 37 minutes, and what they did was rerouted traffic sort of to get around it to come down to sort of the peer network itself.
Let's do a quick roundup of two other outages that have hit your radar recently. YouTube viewers may have experienced playback issues on October the 15th. What happened here, Mike?
So this was an outage that lasted about an hour, and the videos themselves wouldn't play. What happened was you could actually browse YouTube fine, the search worked, the navigation worked, the page loaded normally in terms of you sort of had the stuff out there. But when the playback button was hit, it was actually resulting in sort of blank screens. You couldn't play the video. So what we then saw when we were looking through our tests, we saw the backend services were accepting connections, but they were just hanging. They weren't responding. They weren't actually failing. It was just nothing, which is why we had that sort of black screen themselves. When we looked at this from an HTTP level, we couldn't see any HTTP error code specifically. And this is sort of a sign that we could actually get to the page. We knew the page was loading, but that's what this shows then is the backend services are running, but we actually can't process those requests. And when we're looking from a video, it's effectively a different plugin where we're going to be calling a specific data, we load the manifest and sort of pull that information in. This was kind of fixed within an hour. YouTube sort of fixed it. And the interesting part from this was if you actually look at the infrastructure itself, it actually appeared healthy. The application services themselves were broken. So if I was looking at this from a straight monitoring point of view, looking as I say from the HTTP level, the infrastructure looked healthy. We could get to the system. We could actually make connections. We could load the pages. There was reports, so you could actually run the adverts themselves, or the adverts ran. It was just that when you went to watch a cat video, it actually wouldn't play.
Vodafone UK's network witnessed disruption on October the 13th. What was behind this one?
So this impacted UK customers. It impacted the broadband, the 4G, the 5G, and they're all down for about 2 hours. So what we saw was BGP route withdrawals. This is Vodafone's network disappeared from the internet's routing tables. So their autonomous system numbers were withdrawn from the network itself. Vodafone put this down to a vendor software issue. And what we could tell from that was it sort of impacted the control plane. And when we're thinking about the control plane, it sort of demonstrates a different failure pattern you'd actually see if it was some sort of cable cut or if it was something specific with a route black hole or something like that. The fact we see the control plane means it sort of takes these things down across the board at once. Now, an interesting detail to this was the 2G voice calls and the SMS actually kept working. So it's only the IP services themselves that went down. It meant people could still make phone calls. They just couldn't actually pass data or connect across there. And this had to be I was connected to the 2G network. If I was actually trying to connect across the broadband service and do that, my voice is still traveling over the IP network. So it wasn't that distinction there. It was clearly if I'm actually just passing SMS, which is going across the circuit switch network itself. So this is a couple of things there. We can actually sort of take that as a lesson from a redundancy perspective. In this case, we were talking about different services. But if I apply that to an enterprise environment, it makes the case effective for having redundant networks or having this redundancy capability. So if I actually do lose the connectivity that I'm relying on for my main service, I still have some way of communicating out. The other thing to consider around this was as well that this was a regional outage. Again, so it impacted the UK customers itself. So it was Vodafone's autonomous system networks was actually withdrawn from the environment there. So it was just if I was within Vodafone's network that I actually couldn't get out because I couldn't have a way back in because it wasn't actually advertised. It didn't impact any other Vodafone configurations, any other ASs, and any sort of transit traffic traveling through there. Because the way things are set up with the BGP routing, effectively we sort of go around those situations. We just learn how to get to another path. But when something's actually withdrawn, it disappears. I don't know how to get to it because nobody does.
Thanks for the deep dive into those outages, Mike. Now let's turn to the overall outage trends and what we've seen in recent weeks.
So looking at global outages over the past few weeks, we've seen a downward trend. During October the 6th to the 12th, we observed 185 global outages, which is down 18% from the previous week's 226. That continued a downward trend that started at the end of September and sort of moved away from the elevated plateau of around 300 outages per week we'd seen through most of September. In the week of October the 13th and 19th, we saw a 42% drop down to 107 outages.
And what about the US?
The US followed a similar pattern. On October the 6th to October the 12th, we saw 113 outages, which was down 14% from 132 the previous week. Then October 13th to October the 19th, they dropped to 65 outages, which is a 42% decrease. So over this period from October the 6th to October the 19th, the US accounted for 61% of all observed outages globally. And this was up slightly from the 56% we saw in late September. So while the overall numbers are declining, the US continues to represent a disproportionate share of the global outage activity.
And that's our show. Please give us a follow and leave us a review on your favourite podcast platform. We really appreciate it. And not only does this keep you in the know when a new episode is published, it also helps us to shape the show for you. You can follow us on LinkedIn or X at ThousandEyes, or send questions and feedback to internetreports@thousandeyes.com. Until next time, goodbye.